Hi guys, I'm Luo Binghan. I'm from Jiangxi. Now let me to express these four experience to you. The first one is calculate the speed of light using chocolate bar and microwave. The second is Doppler effect. The third is sonar. The last is pendulum experiment. This is get the speed of the light by using microwave and chocolate. Now, first, I want to introduce the light of speed. The light of speed is a secret theme. Maxwell proposed that the light is the electromagnetic wave equal to the above Weber radio. Maxwell-Morley experiment proved that the speed of light is always same. This is a very important experiment. So, Einstein proposed that speed of light is always same in any reference in the general relativity. Now, if we want to measure the speed of the light according to above theory, we have the formula. C is equal to lambda mu. That means if we want to get the speed of light, we must get the frequency and the wavelength. So we want to use chocolate to measure this, but we must notice that the chocolate must multiply by 2 times because the chocolate is a little small. We can only acquire the half of the wavelength. Now this is my apparatus, and this is my experiment procedure. This is the result. Is 3 times. The real number is this. The wavelength is this. The speed of light is this. The process is 8%. Oh, now we can watch the second experiment, Doppler effect. We can also call Doppler shift. So the object is this. Now I want to introduction this Doppler effect. The Doppler effect is when observed and the emitted source have the relative motion compared to the medium, and the frequency of the observed is different with the emitted source of frequency. The reason is because the wavelength is changed when the observer and emitted object have a relative medium to the medium. The medium speed is constant, so the frequency have a decreasing. When it is named after the Doppler who first described the phenomenon in 1842. In 1848, Witten discovered independently the same phenomenon on electromagnetic wave. In French, the effect is called effect Doppler-Witten. Is an interesting thing. Now, this is the deduce of this formula. The first experiment is the observed is stationary, and this formula is the receiver is stationary. So, and if we multiply by these formulas, we can get the total formula. This is the total formula in Doppler effect about the classical sound wave. Now this is our experiment apparatus, and this is the setup. and this is analyze and conclusion. So, and this is the first setup experiment. In 7 seconds to 20 seconds, the phone is doing the stable pendulum motion. So the frequency and the speed is follow the formula successful. Yeah, this is, and this is the second. This is the second setup experiment. So, and is this, and this is the phone emitted. The wave is stationary. Oh, now let's begin the third experiment, sonar. And the sonar wave can be divided by two kinds. So the Firefox app use the active sonar, and now we can use this to measure the unknown position by active waves. So this is the apparent and the setup. And this is my experiment's result. The process is 0.1. The uncertainty is 0.01. And this is the result, the process, and this is okay. And this is this. And now let's begin the last experiment. Is pendulum. And this pendulum, and we also know pendulum is a very fantastic job. And Italian scientist Galileo was the first to start property of pendulum in 60 seconds. And in 1656, the Dutch scientist built the first pendulum block, and so that means the pendulum is used to calculate accurately time about 250 years. Oh, we can do the force graph. Oh, is this, and this is the time formula, and this is formula, and this is the result, and this is the result. You can get. Now we get 3 graph there, and we want to get the string. So this is the result. Oh, also we want to get the relationship of the period and the root of the length, and so this is the formula, and I think Firefox is according to this to create the data. So I proved the Firefox. Thank you.